Swayam Prabha. Digital India. Educated India.
Welcome learner once again to the MOOC module on handling large scale unit level data using STATA or with STATA. So, this is our week 2, week 2 contains, and where we have been discussing collection of unit level data, and the title of today's lecture is on understanding sample size and its determination. In the last lecture also we have already started with sample size determination. So, today we are going to complete how sample size is determined based on various context. And in last lecture particularly we discussed largely on what do you mean by sample size, okay, and what are the different approaches of getting sample, and what are the different types of sample we have already discussed, probability and non-probability majorly. And now in a nutshell let me mention that in case of non-probability sampling usually the sample size is less, whereas in case of probability 1 we do require more sample. Now it is still very abstract because you know a clear cut idea of sample size is very important. Without that there will be large number of questions on the researchers. So, we have to statistically statistically prove that sample size is of this much, okay, and therefore, further validity or precision of the work is expected. Without that it is actually questionable. So, we have already discussed that. Let me go into the deeper aspects of understanding sample size. So, therefore, the lecture name is sample size determination. This is a continuation of a previous lecture. Now, we have already shown this website. If you just have a click on this link, you will be directed to the calculator for getting the sample size. Here what I wanted to refer for all of you is that which indicators are important for sample size determination. How you could able to assure yourself that your sample size is actually perfectly fine. It may be the case that you have constrained your sample to a limited number, but that number might be attached with huge errors. Okay. So, errors may be of different variety, different types. So, here I am referring to margin error and confidence, with which level of confidence you can say that your margin error is of this much. So, therefore, your result is of this much. Okay. So, in this particular example we have set the margin error, you can manually set here at 5%, 5% level, which is usually acceptable. Till 10% is usually acceptable and statistically proved in different literature and different papers. So, and the confidence level usually of 95, 90 and 99. So, let us be 95 level of confidence. And how big is the population? If your population size is known, if you have a finite population, then this link really works better. That is, if you set 10,000 here as the population, now this will boil down to a sample size of 383 with the fact that you have certain predefined assumptions, that is what is the sample proportion, how much proportion you are supposed to consider out of the total population, who has the probability of how much. If you know that the selection of those cases are of 30%, somewhere some guesstimates are important. If you do a right guesstimates, then usually your sample size is going to be very good. But when you are highly confused about the population, you do not know the near about probability of their inclusion or exclusion. So, in that case you have to assume 50%. So, 50% based on the 50% assumption. So, our result based on this calculator gives 383. So, 383, look at 10,000 of the population, now it has narrowed down to 383. So, therefore, sampling is important. And what is the validity of this 383, how it is important, how do I believe that this is important? We have certain examples to validate. So, let us go by that. Now, here is a picture we have already shown in the last lecture, but I did not explain much because of shortage of time. Here what I refer, given the distribution is normal, we are not even referring to non-normal distribution. It might be it is, I mean, we are assuming that normal distribution has symmetric format, but even if it is symmetric, but it might be a ellipticotic, it might be platycotic, it might be semicotic. So, so there are different distribution. Now, higher the distribution within the normal distribution format, that means higher the stretch, okay, higher the distribution, some variations are expected, higher variations are expected. If it is actually ellipticotic, the mean is not deviated. Here what I refer, let me pinpoint here to the 50% level. So, I am just drawing the 50% or a orthogonal direction to the base at which actually falls at 50%. At 50%, I am just drawing here for you for further clarity. Now, if the distribution is of ellipticotic or the altitude of that is much higher as compared to other, in case of platycotic the distribution is like this is the extreme form of kurtosis. So, if it is ellipticotic, in that case the deviation from the central mean is actually very less. So, since the deviation from the central mean is very less, the errors are expected to be very less. The margin error, that means if you set certain alpha percentage, alpha is the type 1 error as I already referred. What do you mean by that again? Rejecting a null hypothesis when it is actually true. We have collected samples from a population, from a group, from the larger context. You have picked up some sample, based on the sample we determine that you are rejecting the entire population. What do you mean by that? We are simply rejecting the entire bundle based on the sample. It may be the case that whatever you have picked up some errors are actually contained in your sample. So, basically our sampling process with a limited sampling direction may not be justifying the entire population. There must be repeated sample, many samples. Okay. So, if each of the sample are actually giving a central mean having less errors or less deviation from the central mean, all your distribution is nearby the platycotic, nearby the central mean, your mean is not deviated much, that means your sample is actually correct, where we are actually referring to precision of the analysis, or precision higher, the precision higher is also the confidence. So, what is important here? So, I was actually referring how the distribution is actually spreaded. So, now in this particular example, higher if it is ellipticotic, margin error is, look at marginal error is very less, because the alpha percentage is expected to be very less, because the distribution is very symmetric. It is symmetric, but confined to a central mean. Okay. Whereas, when the it is possible when the sample size is actually more. When the sample size is more, you have collected more sample, or the frequency of sample is also more, number of sample is also more, you can test the central mean. Okay. So, error is expected to be very less. Now, so therefore, the marginal error is 2% only in that case. When the sample size is lesser as compared to the first one, your margin error actually increases, because the distribution is now getting less chaotic. Okay. So, and when the sample size is 600, margin error increases. So, therefore, the margin error and sample size are actually inverse related to each other, and this is when it is 96, sample size is only 96, margin error actually increase to 10%, as per an example. This is simply an example. Now, this is mentioned in the diagram here very clearly, you can follow it up and you will find out the correct interpretation. Now, from the same website we can cross check the margin error and as well as the role of confidence level. When the sample size is higher in the first example, your margin error actually decreases. So, you can compare with the increase in sample size as per the first set of example. In the second case, with a margin error of 1%, you require 8763 sample. When you have the freedom to go for little higher margin error, okay, in some cases in order to contain your budget, restrict your budget, you may accept that a 5% is fine, till 10% is generally acceptable. So, you can stretch your margin error to little higher level, so that your sample collection sample size you require little lesser. Okay. So, therefore, second one is those is just the opposite, but it is important so far as sample size is concerned. Okay. In the third case, we are referring to the confidence level. The confidence level matters how confidently we deal with our both the direction sample size. Higher the confidence level, higher, to make your confidence level higher, you are supposed to collect more sample. So, sample size is positively linked. Okay. And so, if your population itself is very high, you are bound to actually go for higher sample size. So, in all the case sample size is actually referred. If the with the same with a sample proportion of 10%, sample proportion is 10%, your sample size will be 139. If your sample proportion or probability of inclusion is 80%, you have to if it is 20%, there are different brackets given, you can calculate. So, you can find different sample size based on sample proportions. So, we will take use of all those in our equation. The equation will clarify what sample proportion and why these rates are different. Somewhere it is higher, somewhere it is lower, we will find out from a mathematical equation. Okay. Now, what are the approaches for determining the sample size? It is precisely based on the confidence level as well as precision rate, the rate at which the precision is made. To specify the precision of estimation desired and then to determine the sample size necessary to ensure it, we do require mathematical solution as well as frequently used techniques. Okay. So, some mathematical solution is needed to justify the sample size correctly, and also some frequently techniques, standard techniques are required, like as I told you, there are some conventional method, some convenience sampling method, purposive sampling method, snowball sampling method, non-probabilistic method, where we know certain frequently techniques. So, from those reasons we can able to reduce the sample size, or our precision is expected to be much higher. And if we have hired a very good local an investigator having very good knowledge about the local areas, so you need not actually collect more sample, because the local area local area investigator, the investigator having local knowledge could actually infer many better information. Okay. So, what are the limitation in this case? The limitation is it does not analyze the cost of gathering information. So far as precision rate in confidence is concerned, cost of the information is not discussed. When the cost is discussed, it gets complicated. Usually we refer in the context of Bayesian statistics. So, the Bayesian statistics usually take care of cost aspect too is also, though it is very complicated statistically. Now, so the Bayesian approaches uses the way I mean basically uses Bayesian statistics, I mean the approach based on Bayesian statistics uses Bayesian statistics also to weigh the cost of additional information against the expected value of the additional information. So, so as I already mentioned, we do require cost of additional information, which is very essential, and it is theoretically optimal. First important point. Second is it is seldom used because of the difficulties involved in measuring the value of the information. Now, look at the classical way of inference, and in the second one is Bayesian inference. So, in the statistical inference we can also able to conclude, and in this case also we can conclude systematically, but Bayesian inference do require prior information. This is quite important. So, the Bayesian statistical analysis incorporates a prior probability distribution and likelihood of observed data to determine a posterior probability distribution of the events. Now, let us stick to or let us analyze the mathematical approach of understanding the precision rate and confidence level, and so on we can able to define the right value or number of the sample. The sample size can be actually determined based in the standard formula. Now, let me proceed to an equation from the beginning. As we all know that first of all, any data we have, our duty is to convert the data to a standard normal distribution. Standard normal distribution looks like this. So, let me draw here, it looks like this. So, why standard normal distribution is important? Because it simplifies the data, okay. It centers the mean across the distribution, and accordingly we can have lots of projection, and it simplifies the data, okay, and it makes the data symmetric. If the distribution is standard normal, then the data gets symmetric. So, how to get a standard normal distribution? Usually denoted by Z. So, Z is equal to x minus mu divided by standard deviation, okay. So, x minus mu by standard deviation. Now, if you if you have certain finite population or infinite population, there are two approaches of understanding this. Sigma is actually quite important to read here, because it is not just sigma, it is the actual formula of Zi is equal to sum of I varies from 1 to n xi and this is sum of mu divided by n, okay. So, sum of I varies from 1 to n xi minus mu divided by standard deviation. Now, so basically when we take it, this is actually equal to x bar I mean sample mean minus population mean, mu stands for population mean, and the sum of the standard deviation is actually divided by n, square root of n, it is actually sigma square divided by n. So, it will be equal to sigma square root of n. If we take the right approach of it, we can find out accordingly. Now, if I just convert the equation in terms of mu is equal to so this will be equal to x bar, because I have taken sum of I varies from 1 to n divided by n into xi. So, it will be x bar plus now I mean if I am interested in calculating the confidence interval Ci. I have already discussed that confidence interval. These are actually the intervals from the central mean, okay. Now, if we set the confidence interval at this is at 99% or 99%, 95% or it is at 90% confidence level, actually when it is 99% it covers 99% of the information, okay. And usually the errors are very less, okay. Usually when the confidence level is very high, the precision rate is also quite better, okay. And or the precision or the error, margin error is actually very less. Now in this case, in order to define the confidence interval of the mu, so it will be plus minus of standard deviation, because the distribution is varies from the x bar plus 1 standard deviation plus 2 standard deviation plus 3 standard deviation, depending upon the distribution we have. So now what we have, if I just simply multiply here, it will be z times sigma square root of n, okay. So now let me move to the original equation. It is clearly given here. So now based on when we have a sample size and the population is not known, what is the total population is actually not known. When we are estimating a mean, the confidence interval for the universe mean, that is mu, is equal to, we are actually estimating the confidence interval x bar plus minus, we have already discussed this, plus minus here, plus minus z times sigma by square root of n. This is I have already derived in the plain sheet and plain page. So now from here, if I flip the equation, so basically what is the error here? Now basically your population mean or the universal mean is actually centered around the sample mean, that is x bar, with error of z times sigma of square root sigma of 1 upon square root of n, okay. So this is basically the extent of error we have, margin error. The margin error, the precision rate we are going to find out is actually through this. Now this is correctly mentioned in this particular example. So how we could do it if we just adjust the equation. From here, this is E is equal to, here is given as z times sigma upon square root of n. Now n is the population size of the population, and small n is size of sample, and E is acceptable error, that is also called precision, okay. Now n is the population n, but population n is not given, as I already mentioned. If it is not known, and this is the formula. Now what do you mean by sigma p here? Standard deviation of population is as called sigma p. So what is required in this equation? We should have certain information about the standard deviation, how the population is actually distributed, okay. What is the approximate value of the distribution of that particular area or the population. So standard deviation of the population, not the sample, and z is standard variate or standard variate at a given confidence level. So now if we further adjust it, so this equation is given here. Now n, if I calculate further, it is actually, I will take E here. So square root of n is equal to z times sigma divided by E. So now n boils down to z square, it is already given, times sigma square divided by E square, alright. So E is calculated, this is what E is defined. So E is calculated, and this is what the sample size, n, small n stands for the sample size. So sample size is correctly estimated. Now if these information are there, you have a standard Z table usually is available. So if Z table is available and some idea of some population distribution is given, and sample margin error is calculated and is known, then we can find out the sample size. Now if we have a finite population and population is known, the correct equation for it is this is the equation earlier we have. We just need to subtract the net population after the total population. So, this net population divided by a capital N minus 1, that is total population population minus 1, and 1 is deducted because of the degrees of freedom constant due to the sampling distribution. Since the sample is considered and sample due to the degrees of freedom reduced by 1, we can adjust with the degrees of freedom by dividing to it. So, since it is divided, the total population is known, and the probability of not getting selected with respect to the total population, it is given here. So, that ratio is also multiplied here. The probability of non getting selected is also multiplied here, and if that is there, accordingly we can calculate the margin error or the acceptable error, and accordingly we define the sample size. How to get it? You first convert that equation. How to convert that equation? We are interested in in calculating. This is basically mu is equal to x bar plus minus z sigma square root of n. Now, we are actually multiplying the probability, I mean the proportion, not probability, the proportion of non inclusion, and that is square root of capital N minus n divided by n minus 1. Okay. So, this is multiplied, and now we take it. So, so our error term, I mean margin error is actually explained by this. Now, I am interested in calculating small n. So, small n can be taken to this side. So, first step is you just simply take square root of n here, and your z is here, it is sigma divided by, now e is defined here, this is the same n minus square root of n minus small n to n minus 1, the square root is given here. Now, the n is defined as then z square sigma square divided by e square. So, now all the terms are actually avoided with square root, this will be n minus 1. Now, still there are small n contents on the right hand side. So, if I simply take here, okay. So, what I will do, I will actually take multiply this with n, I can take like this, n capital N minus n and z square. So, rest will be there, z square sigma square divided by capital N minus 1 times e square. So, this can be presented there. Now, you simply subtract. So, you take multiply right hand side by capital N minus 1, now n minus n. So, next step would certainly be n is equal to, so n times of this, I am just multiplying this, and minus small n times of this, and this is here. Now, what you will do, you take small n to the left hand side and start solving it, you will certainly get the final equation is z square times n multiplied by this, and this is the final equation. Once we have defined the correct n when the finite population is there, we can able to solve many equations. Now, how to determine the sample size? If one example is before us, how to determine the sample size for estimating the true value of the serial containers for the universe with a population of 5000 on the basis of the following information. The variance of the weight is 4 ounce, and the estimate should be within 0.8 ounce of the true average weight with 99 probability. So, what is given? The E is given, Z value is given, Z is I mean not Z, the confidence level is given, confidence level is of 99%, and E value is, that is 0.8, and the variance is also given, variance not the standard deviation. So, variance is here is 4 Okay, so all those information are given, we can simply put this information and find out the correct sample size. Now n is given, population n is given, the population variance is that variance is 4, so the standard deviation will be 2. Now margin error we have already defined, that is 0.8 was given, and the Z value for the 99 percentage, 99 level of confidence, if you go by the Z table, the Z table will give you a value of 2.57. There are other one, let me just show you here. Now for the Z table, for 99 level it is 2.58, for 95% it is 1.96. This is a standard Z value if the confidence level is given. So for 90% confidence level, it is of 1.645. Okay. So so it is of 1.645. Now how could we able to understand this correctly? Now if we interpret 1.645 is a standard Z value at different level, 1.645, 1.96 and 2.558 for 99% level of confidence. Now if I use that for 2.58 or 2.57 is given, it is actually 2.58. So for Z of 2.58, if I interpret everywhere, this is 2.58, capital N is 5000, sigma square is our 4, that is sigma is 2 and n minus 1, E value is 0.8, then rest are given. So if you just put all the values, this boils down to a sample size of 40.95, that is precisely 41. Now how could I interpret this? Out of 5000 population size, we can derive the sample size, or sample size is determined as 41. It has actually minimized, but so many information must have been given. There are some certain standard rule are determining, like margin error, some guesstimates are required, Z value, confidence level are generally set at 90%, so 95% and 99% level. So standard Z table value has to be remembered or should be checked through the table. These are informed. A variance is very tricky, it is not that easy to determine. So if some information regarding the population variance and population size is important, so far as this method is there to apply. So therefore this method is little complicated. Some new methods are actually suggested based on other information. Now what is important to be noted here is that we are supposed to follow certain techniques when we have certain other information, like all those information are not given, only sample proportions are given, okay, percentages are given or proportions are given. If only limited information are given, some specific answers or equations are therefore referred. So what do you mean by that? Like certain population proportion information is given, either success or failure, okay, probability of success and failure information is given to you, okay. So in that case the distribution is not normal, it is not at a normal distribution. When your population is not of normal, okay, and you cannot convert that population to a normal distribution, and it will be a Poisson distribution type, P and Q, that is probability of success and probability of failure, okay, 1 minus P, that is Q is given. So if it is a Poisson distribution, then it is not that easy to apply the same rule we have derived. So value of the standard variate at a given confidence level and to be worked out from the table showing area under normal curve. Basically when you convert that through a normal curve, it is very challenging, and accordingly a different formula is applied, okay. If P and Q is there, so standard table or the standard Z distribution is tricky to determine. If that is determined, then we can define accordingly. So I think I have already exceeded the limit of 30 minutes today. So what I will do, I will keep rest of the contents for the next lecture, and because we have very interesting part, let me just have a overview of it. We will carry forward this content in the next class, because those who do ground level research, they do require less information for better calculation. Okay. So, these are still there, we will discuss in the next class. Okay. Let me stop here. Thank you.